Hi folks, today we're going to look at dividing by a fraction. Students may be taught to perform a memorised process when presented with an abstract calculation like 5 divided by 2/3. The process for dividing by a fraction is relatively simple to follow. This may be done using keep, change, flip. Keep the whole number we're dividing, change the sign from division to multiplication, and flip the fraction so instead of 2/3 we have 3/2. We can then multiply the fraction to get 15/2 or 7.5. But why do we do this? Mathematical concepts and relationships are connected. Effective progression in maths relies on students' ability to understand and make those connections. So while we might get so far memorising and just doing maths, all students will progress further if they're taught to understand. To do this, setting the problem in a context is essential. And before we can divide a fraction, we must first understand sharing and grouping. Let's consider a group of 12 players who we want to divide into 3 equal teams. Let's start with a bar to represent the whole amount. We'll split it into 3 equal parts because we want to make 3 teams. Then we can share out the players. This can be done one at a time, or students might do this more efficiently by sharing out 2, 3, or even all 4 at once. Let's now consider the same 12 players, but this time we want to split them into teams of 3. We can draw the bar again to represent the whole amount, but this time we don't know how many parts to split it into because we don't know the number of teams. In order to solve this problem, students will naturally group. Let's make a group of 3, then another, and another until all the players have been put into a team. The context supports students' decision making and apply their mathematical reasoning. The first scenario naturally led to sharing, while the second leads to grouping. We don't develop an understanding of these relationships when we teach the algorithm on its own. Let's apply this understanding to our division calculation. If I only understand division as sharing, I'm going to struggle to contextualise this. What's 5 cartons of orange juice shared between 2/3 of a person? What does that even mean? Let's now consider a grouping example. 12 divided by 3 can be thought of as how many lots of 3 can I get from 12? So how many lots of 2/3 can I get from 5? Let's consider the following question. A glass holds 2/3 of a carton of orange juice. How many glasses can be poured from 5 cartons? Let's start with 5 bars to represent the 5 cartons. A glass holds 2/3 of a carton, so we need to split our cartons into thirds. A full glass holds 2 of these thirds, so we can represent a glass with 2 of those parts. We can pour out the cartons 2/3 at a time to fill a glass at a time. Until we've filled 7 full glasses. And we're left with 1/3 of a carton. What happens when we pour this last third of a carton into that 8th glass? It fills half of the glass. So the answer we get is 7.5 glasses. The thirds relate to a carton, the resultant half relates to a glass. That's how we end up with halves in our answer when we start dividing by thirds. So there's no need for an abstract process that students don't understand. In fact, by developing this concept through a context, we're supporting students develop and apply their mathematical reasoning and actually understand what and why they're doing it. This will allow them to make connections to related concepts and ultimately allow them to progress further. And by visualising fractions rather than relying on fractional notation, they're developing a deeper understanding of fractions. You can find more of my videos on my YouTube channel, Scott Morrow Maths, and you can follow me on Twitter @ScottMorrowSA. Thanks for watching.